Okay, class. So, very good morning. Welcome to the briefing section on practical laboratories. So, make sure, class, everyone is here. So, I am Dr. Mugunda here. I hope everyone, I think you guys know me or seen me before. So, class, now these are the list of students that given. Okay, I will add Najiha Tahe in the group as well. So, class, before we start our briefing, so I just would like to introduce about the rubric system. So, class, kindly get your lab manual here. Your lab manual, please. Okay, keep your lab manual with you now. So, I will start the briefing. So, class, now basically in the first page of your lab manual, okay, in the page number in your lab manual for SID 2003, you have the rubrics. Am I right, class? So you may use the rubrics here. Okay, I already put it in the slide as well for your information. Okay, so the rubric is actually, class, for the lab reports only. Okay, so total marks for the lab report will be 60%, and there is another 20% for the understanding, okay, or on the conducted experiments. So class, is my voice is clear? Anyone kindly reply. Okay, good. Okay, I may proceed. Okay, so class, now we have these are the list of experiment that we are that you have to prepare the lab report, okay, without doing the experiment physically. So experiment 2, which is complexometry titration of metal ions, and experiment 3 will be spectrophotometric determination of manganese in steel. Experiment 4 will be analysis of trace metals by flame emission and atomic absorption spectrometry. Experiment 6 will be introduction to gas chromatography, and experiment 7 will be determination of fluoride using specific ion electrode. So, class, here we have proposed 5 experiment, okay, for this cycle, and the rubric for the lab reports, okay, it's the same rubric here, class. So we have introduction, which is, the allocated mark is 15. If let's say any information is lack, or if I feel like it's a bit moderate, then you won't get a full mark. Okay, so I will mark according to rubric. If you can feel the requirement of the lab report according to the, if you can do your lab report according to the given rubric, it will be really good, because you can get full mark. So for introduction 15, you are entitled to get full marks is 15. Okay, but you have to fulfill all the criteria given to get the full mark. And for experimental section, the allocated mark is 15. Again, okay, you can check all the given the allocated marks, okay, for what type of experimental informations. And as for the results, okay, and results, usually how you are going to present your results. Okay, results and discussion, actually. So you will have for results, the allocated mark is 20. Okay, and so discussion is 20, conclusion 10, reference is 5, so total is 100 marks. So class, kindly include these as well, and title 5 marks, objective 10 marks. So total, the marks will be 100. Okay, and there is another one portion, which is the assessment of understanding of the conducted experiment, which is 20%. Okay, this one is actually for the experiment number 4. Okay, the understanding is experiment number 4. So the rest is based on lab report. Okay, so but whatever also class the total lab reports. Okay, I will count as for the 100 marks. Okay, the understanding is actually this criteria is I will evaluate for the experiment number 4. So let me explain. So class here you can refer your lab manual. So we have created a online lab manual. So have shared the link in your spectrum. You can click the link. So when you click the link class, it will direct you to the lab report. Okay, so these are the practical section via e-learning lab manuals. So class, in your current lab manual is just you have the information about how to do the experiment and all those things, but in this lab report you may refer both. Okay, so in this lab report we have given you the results as well. Okay, so that you can interpret the results and do the lab report. Okay, so you probably you have to, I mean, you have to click the link and it will direct you to the experiment number 2 here. So class, before go into the experiment, I would like to explain the information. Okay, so class, first briefing it's today on 18th of May, and second briefing will be on 8th of June 2020. So only one full report have to submit according to the rubric given. That means class, the one full report should have the, starting from everything like objective, everything should be there. Okay, full lab report, and the rest is only results, discussion, conclusion and references. Okay, so we have 5 experiment. Okay, only one full report you have to submit. The rest is only results and discussion, conclusion and references. Okay, so first 3 experiment you have to submit by 8th of June, and the last 2 experiment you have to submit by 22nd of June. So class, today I will brief on only 3 experiments. Another 2 experiment I will brief on 8th of June. Okay, so that I will make sure these 3 experiment you have to submit. Then another 2 you can submit after, you can do after the briefing. Okay, on 8th June. So let's move on to the experiment number 2. So class, any questions on rubric? Is rubric clear? Clear. Okay. Thank you. So now experiment number 2 class. Okay. So class, basically in this experiment, we are going to learn about the complexometry titration of metal ions. So the learning objective for this experiment is to understand and apply the concept of titration of metals by chelating agents such as EDTA. Okay, so and this is very important class. Okay, you have to know the basics of EDTA now, so that in your second year, again you will do this. Okay, so determine the concentration of metal ions using complexometry titration techniques, and determine the concentration of metal ions in the mixture by pH adjustment and masking agent. So class, basically what is complexometry titration? Actually, complexometry titration are useful for determination of a mixture of different types of metal ions in solution. Usually most widely used ligands are ethylene diamine tetraacetic acid, which is EDTA, which forms one-to-one complexes with any metal ions. Because EDTA is will act as the ligands. It is an ligand, so it will form complexes with the metal ions, and the resulting metal ion complex in which the EDTA forms, usually it will be in a cage like structure around the metal ion, and it is very stable. Okay, so the availability of the ligand that gives a single and easily identify endpoint made the complex action titration a practical analytical method for the quantification of metal ions in solution. So class, basically EDTA is an selecting agent that binds to metals through 4 carboxylic acid. You can check the structure of EDTA. Okay, and the formation constant for the complexation is different for each metal because the ligands are acids, and the formation constant are also strongly dependent on pH. So the metals always binds more strongly as pH increases because acidic hydrogens are removed from the EDTA. So basically class, in this experiment pH adjustment is very important. So here we will introduce about direct titration and back titration. You should know the difference between what is the meaning of direct titration and back titration. Okay, so direct titration is actually class, you may simply add an indicator to a metal ion solution and you can titrate with EDTA. It's similar to normal titration. While back titration is actually an excess of EDTA will be added to the metal ion solution and the mixture will be titrated with the known concentration of a second metal ion. So that is the difference of back titration and direct titration and back titration. So basically back titration is a bit different. So the second metal ion will form complex with the excess of the EDTA molecules until the endpoints where all the excess EDTA has been completed. So class, if we check the okay, let's I will go to the link. Okay, link of the experiment. So class, this is how the page will appear, the Google page will appear. So you have to click experiment number 2 here. So the introduction of what is actually complexometry titration. So here class, we are going to determine the metal concentration by using ligands. So the ligands are EDTA. Why we are using ligands? Because ligands can form complexes with metals. Okay, but this titration we have to do in the presence of indicator. Okay, so now an indicator and we will use masking agents as well. Okay, so here class, the explanation about the EDTA, the introduction is given here. So you can observe table 1, the indicator used in complexometry titration. For example class, if let's say number of the indicator, okay, if let's say they use this kind of indicator, so the color changes here, the pH range, so the metal detected what type of metal. So this is for the general use. So class, this curve is very important. The volume of EDTA added, okay, so this is consider excess of uh, the ions left after the each addition of EDTA. This is concentration of free metal equal to concentration of unreacted of Mn plus, and these are the reagent where the equivalent point. Okay, equivalent point. And this is the excess of EDTA. So class, we will use mangan in this experiment. So we have direct titration and back titration. So let's watch the basic idea. Actually, what is complexometry titration? If you observe here class, okay, let me play again. Okay, if you observe here, the metals, okay, the metals higher. So the EBT is added, so it will form some temporary medium here. Then EDTA will be added at pH 10. EDTA will be titrated. Then calcium will bind with EDTA and EBT will be out. So this is actually complexometry titration. Okay, it's a quantitative way to determine the metal concentration. So class, in the presence of EDTA, when you titrate with EDTA, some metal will show the color. You can observe some color changes. So through that color changes, we can know what type of metal is that. Okay, so now I hope you know the difference between direct titration and back titration. So in this experiment class, the first thing we have to do is we have to standardize the EDTA. This is very, very important. Okay, you have to standardize the EDTA in the lab. Okay, once you have standardized the EDTA, you have prepared the EDTA. Okay, you may start to determine the concentration of the bismuth and lead by pH adjustment. Okay, this is by using normal titration. And second, determination of cadmium and mercury by using back titration and masking agents. So all the procedures is already clear here. So class, any questions so far on the methodology introduction? You can get the basic idea what is complexometry, class. Anyone kindly please reply. Clear? Is this clear, class? Class? Okay, good. Thanks, Darshini. Okay, now let's move on to the okay, the results and discussion. So class, the results given here is actually a standardization of EDTA. So the volume of EDTA used, okay, and initial volume, final volume, the volume used. So, and this is the determination of bismuth and lead in an unknown, okay, and there is a procedure before and after addition of hexamine, okay, how much volume we use, okay, and third one will be the determination of cadmium and mercury in unknown samples. So the volume of zinc will be used to determine the cadmium and mercury. So these are the results, okay, the past year results that we have tabulated for you all. So class, based on all these results, okay, and after the addition of potassium iodide here. So class, here hexamine and here iodide, okay. So you have to use the table, the results given here, and kindly you have to answer this question. So based on the data given, explain the reaction involved using the equation and calculate the concentration of the metal ion in the mixture in gram per decimeter cube, and explain how each metal was able to detected separately from one another, and the report should include the answer to the questions as well. So what is the function of ammonia buffer for the back titration, and explain why zinc solution was used as the titrant for determination of mercury and cadmium. And you may relate your answer to the metal complex formation constant. So class, you do have some extra additional videos, okay, for your understanding here. Okay, you may refer for your further information. So class, with that, we have done the explanation for experiment number 2. So I will move on to the experiment number 3. Okay, so in this experiment class, we are going to determine manganese in steel, okay, via spectrophotometry determination. So class, spectrophotometry detection, okay, what is the learning objective of this experiment is actually the students should able to understand and apply Beer's law in spectrochemical analysis, and to determine spectrometrically manganese as permanganate ion in steel. Okay, so the introduction for the manganese is here, class. Okay, and I have given the theory on UV visible measurement. So class, what is Beer-Lambert law? So as we increase the concentration, the absorbance is increased. It's directly proportional to the absorber. Concentration is directly proportional to the absorbance. So that is what proposed by the Beer's law. Okay, so you may watch this video. For example, class, okay, it's just a example how to plot the calibration curve. So the concentration, the absorbance. So how to plot the calibration curve using the values given in a class. So it's just just I just want to show, okay, as we increase the concentration. So class here, as we increase the concentration increase, the absorbance value also increase. So this is what proposed by the Beers-Lambert's law. Okay, so class, you may watch all these videos, okay, for your understanding. So in this experiment class, manganese in steel can be quantified by oxidizing manganese Mn to MnO4 minus, okay, which has intense purple color. So the concentration of manganese can then be determined by measuring the intensity of purple color and comparing it with the color of known permanganate solution. So the procedure is actually, you can go through the your lab manual. So this is the demo and practical experiment. Okay, this is the how to run UV spectrophotometer. So class, in we will use a QWET cell, okay, and we will run with the blank and samples. Okay, you may watch this video, okay, to get a clear picture how to run UV spectrophotometer. So all these you can find in your lab report. So class, here standardization of permanganate with oxalate. Okay, you have to do the procedure, and you have to determine the calibration curve. Okay, and finally you have to determine the manganese in steel concentration. So class, the let's move on to the results part. Okay, class, another important thing, when we measure UV spectrophotometer, always we must measure the absorbance of the solution and the blank using a distilled water as a reference solution. Okay, so let's move on to the results part. So here class, table 3.1 shows the absorption data of 5 solution using spectrophotometer at 525 nanometer. So here class, we have 5 different concentration and the absorbent value. So as you can observe here, as we increase the concentration, the absorbent value is also increase. Okay, so these are the concentration of MnO4 in steel sample and its absorbent. So class, here you have your absorbent value. Okay, solution 1 treated with KiO4, solution 2 not treated with KiO4, solution B1 treated with KiO4, and solution B2 not treated with KiO4. So class, I have assumed that you have gone through your lab report, so that okay, I no need to go through much on the method part. Okay, I'm explaining the results and discussion part. So class, how to calculate the concentration here? Okay, from this table, you can plot calibration curve. Okay, calibration curve by using this Excel method. Am I right, class? So when you plot your calibration curve, you will get your equation y equals to mx plus c. So y will represent the absorbent and x will represent the concentration. So class, here you have one treated with KiO4, not treated with KiO4. Solution B1 also same. So in this method class, so how you are going to get the concentration of solution A and B? So the concentration of solution A and B, the absorbent will be class. You have to minus with and without. Treated with and without. Okay, this is considered error. Okay, something like as a blank. Okay, you have to minus. So you will get your absorbent value here. So when you get your absorbent value here, you can substitute in the calibration curve formula to find the concentration. Okay, you may find the concentration. Okay, you may substitute the absorbent in the formula and get the concentration. And end of the day, you may minus these two concentration and these two concentration. Okay, and you will get the final concentration here. Okay, so and given that class, the mass of steel sample that when we weigh, okay, for example, sample A, sample B, and mass of KiO4 in sample A, sample B. So it's just for your references. Okay, so for further information, you can refer this PDF as well, class. And okay, here basically you have to plot calibration curve and calculate the concentration of the MnO4. Okay, after you have, if you have minus with the interference, okay, you have to minus with the interference which is not treated. Okay, the data of not treated with KiO4. Okay, and here, okay, you have the questions to answer. Okay, so what is the purpose of the following chemicals in this experiment? Briefly discuss their purpose and the chemical reaction involved. Okay, so what is the purpose of all these? Okay, and you may refer to this reference class for further information. Okay, so class, we have done experiment 2 and experiment 3. So let's move on to the experiment number 4. So class, as for the experiment number 4, actually I have created the experiment, but it's about the interference study. But you can't write the report without doing the experiment. It's very difficult. So at last we have created another one alternative task of assignment, which is, I believe that you are learning about AAS and AES in your lecture. So, can you write a short description on how the AAS and AES produce signal from metals and can be used for the quantitative analysis? Okay, maximum you have to write for only one page. Okay, this is experiment number 4. So, class, for experiment number 4, okay, I will refer no lab reports. Experiment number 4 is no lab report, it's just an assignment. And the rubric that I will follow to mark experiment number 4 is this: the understanding of the conducted experiment. So for experiment number 4, I will mark with this. So the rest I will follow this rubric. Okay, so class, can we decide which experiment you have to I mean, in this group you want to do full report? Can I suggest experiment number 6 as a full report? The rest is only results, discussion, conclusion, and references. Is that okay, class? So in this group, only experiment 6, okay, you have to do full report. Full report means, class, according to the rubric. For example, title, objective, introduction, experimental, results, discussion, conclusion, references. All these elements should be included in experiment number 6, which is introduction to gas chromatography. So experiment 2, experiment 3, and experiment 7 is only results, discussion, conclusion, and references. Class, results and discussion, okay, you may plot results in different way as well. Okay, the one that we gave you is just for the guidance. You may present your data in different way, and you may show some calculations, your statistical calculation, whatever. Okay, and you have to discuss your results, and you have to conclude, and you have to give recommendation. So class, where in your conclusion kindly give some, some safety, or in your discussion you can give some safety precautions, and in your conclusion you can give some recommendations. Okay, future recommendation, or what should do or what shouldn't do, or something like that. You may explain that in discussion, um discussion and conclusion. Okay, it's up to you, class. Okay, but make sure the precautions is included, safety precautions included in the discussion, and conclusion you must include the future recommendations. Okay, so the next briefing, class, will be on 8th of June. Okay, in the second briefing, I will brief on experiment number 6 and experiment number 7. So class, the link, the created link is, I hope it's very clear. Let me open the link again. So class, here experiment, okay, you have to go home. Okay, experiment 2 is here. Experiment experiment 3. Okay class, don't choose this experiment number 4. We are not doing this full report for experiment number 4. Okay, since you won't learn about interference now in your lecture. So I have created another one alternative. Okay, you must click this. Okay, so all the information about the flame emission and atomic spectrometry, it's here. Okay, let me introduce a bit class. Okay, the all the information is here. So the task of assignment is also given here. Okay, you may refer to this page. So basically class, flame emission and atomic absorption spectrometry are analytical tool to determine the concentration of metals in sample. So atomic absorption spectrometry is very common one, and this instrument can able to perform both AES and AAS. Okay, so and this technique is basically AAS method, and this instrument can able to perform atomic emission spectrometry and flame atomic absorption spectrometry. So it can able to perform both. Okay, so depending on the element under the analysis, so various type of flame we have to use. Okay, according to the metal, different flames will be used. So these are the flow chart how it works class. Okay, this is AAS. Okay, we have cathode lamp here, flame, nebulizer. So class, the basic idea, when we introduce the sample will undergo the atomization process. So nebulization, desolvation, volatilization, it's changed to the gaseous molecule and dissociate as the atom, and it will be detected as a metal. So this is the basic idea of the instrument. So class, the difference between AAS and, okay, this is the flame atomic absorption spectrometry, and this is flame atomic emission spectrometry. So here they use the flame, okay, nebulizer, okay, all these, okay, same. Okay, just that here we have uh, ACL, which is halo cathode lamp here, while flame emission spectrometry, okay, we don't have the HCl here. So halo cathode lamp, okay, make the electrons excited, okay, and in the excited state, and it will go to the absorption, this one. But here for AES they use flame, okay, for the electrons to excited. Okay, so class, you may read more about the definition of AAS and AES, the difference, and how, okay, it AES and AAS are using to determine. So class, basically, before we run any metals, for example, I want to run zinc, I will prepare a zinc standard solution, okay, with different concentration. For example, I in my sample I want to detect the concentration of zinc. So before I detect my real sample, I have to plot calibration curve. Okay, this is the through calibration curve we can quantify the amount of zinc in the sample. So here, how we are going to plot the calibration curve? So back to the Beers-Lambert law. As we increase the concentration, the absorbent value will increase. So how we are going to plot the calibration curve? We are going to use the standards that available in our lab. For example, if we want to conduct zinc analysis, we will provide the zinc standard for you, so you can prepare the zinc standard solution at various concentration by using M1 V1 equals to M2 V2 dilution formula. So when you prepare different concentration of zinc standard, and when you run AAS and AES, the signals or absorbance will increase as increase the concentration. So basically you can get a I mean you can get a straight line something like this, and we will get the formula y equals to mx plus c. So as for the unknown sample, we can, when we run unknown sample in the instrument, we will get the signal. So with that signal we can use the line, by right we can use this method, and the concentration can be calculated here, or we can use the formula which is y equals to mx plus c. Y usually will represent absorbance or intensity. X will be the concentration of the unknown. You can use Excel method. Okay, you may refer to the Excel file that I have shared in the experiment number 3 for your information. So class, these are the tasks for the experiment number 4. Okay, so experiment number 4, class, please use the alternative one. Don't do this experiment number 4. Only 2, 3 and 4 alternative. Please take note on this. Okay, and you have to submit all these by the full report. The first 3 experiments have to submit by 8th of June, and the last 2 by 22nd of June. Okay, and 8 June we will meet again for second briefing, okay, to explain about the experiment number 6 and 7. So class, with that, any question that you have to ask, class? And I will create the link in your Spectrum. Okay, you may submit the lab report via Spectrum, and class, again kindly log in your attendance there. Okay, and the slide of this slide also I will share in the Spectrum. Okay, so anything else, class, that you guys miss, or you are still unclear? Anything, you may type here, class, if you don't want to talk. Hello, class, is that okay, clear? Okay, so no doctor, all good. Okay, so in that case, class, thank you so much. If you have any questions or anything, you may WhatsApp in the group that I have created. So thank you so much for your participation, class. Okay, so again, kindly log in your attendance, okay, via Spectrum. And thank you so much. Stay safe, class. Okay, be safe, be at stay at home, and be safe always. Thank you so much, class, for your cooperation.